Finally moving on maybe to 2.4, we'll look at primitive data types. Now, it's not that they have opposable thumbs. It's not that, they can't drive cars. It's that a primitive data type is actually baked into the very core of everything that makes Java. So these are data types that you do not have to describe to Java. They're automatically in there. So I know that doesn't make a ton of difference just yet. This is starting on page 46, but the primitive data types are as follows. A byte. The rationale to having a byte type is that it only maintains 1 byte of data as far as size goes, as far as storage location goes. So these are really very, very, very small as far as a computer is concerned. A byte can only be an integer from -128 and then 0 clearly to positive 127. So if you're looking at things like a month code for the year, those are 1 through 12. A byte makes a lot of sense because it's super duper small. However, you don't see this a ton when you're looking at, I'm going to call it modern Java developments. We would absolutely positively use a byte if we were trying to put something on the moon, because every last little storage location counts. But when it comes to, writing a DVR piece of software, we really wouldn't bother with that. A short is larger than a byte. My mouse is flipping out. A short is larger than a byte. You can see it takes up about twice the amount of storage space, and it is much larger in terms of the range of numbers that you can use. However, again, you're probably not going to use those. For the most part, when we are working with a whole number, you are going to use an integer, so an int data type. Yes, it's true, it uses 4 bytes of storage, but look at the number, the sheer number of integer values from, -2,147,483,648 to the positive end of that, -1. That gives you a boatload of numbers to work with. A long gives you even more whole numbers rather, to work with. So if you're thinking about things like cosmic distances, right? So the difference between the Milky Way and the next galaxy in terms of meters, we're going to need something like a long, because that's a huge amount of difference. A floating point number, next down our list here, contains decimals. That's really the difference between int, long, and float is float. Finally, we have a decimal value there with 7 digits of accuracy. So a float would not be good for things, again, like cosmic distances or like astronomical units of things, because it's just not accurate enough. But what it is accurate enough for is things like a tax code, right? So what is the percent of taxes you pay when you go to Beefaroo? Well, here, that's something that we could use a floating point number for. On the other side of that, a double is even more accurate, 15 digits of accuracy. So that is more accurate, but again, it takes up more storage there. So depending on your application, you may need to be super aware of storage. But what I'll tell you is, for our applications, we do not need to be super aware of storage. For the most part, you will stick with integer and double, frankly, as far as the primitive data types that you are going to need to be successful here with the Java course.